Hello, welcome to Berkshire Guitar Amplifier Repairs. Stuart Smith with you as always, and on the bench today we have a mystery package. Christmas has come early. I don't very often get amps posted to me, but this person saw one of my YouTube videos where I refurbished a Selmer amplifier from the 60s, and guess what's in here? It's another Selmer amplifier from the 60s. So let's get the package undone, have a look, see what's inside and see what we're dealing with here. Right, here we go. I want to try to reuse this box if I can. Not very obvious how it's put together actually. Let's go along here first of all. Yeah, I think this is the way in. I think I might pack it a little bit better than this one, send it back to him. This is just a thin 2-wall cardboard box here. It's in bubble wrap, so it should be okay. And it's not terribly heavy. Oh, no, there we go. Let's get the bubble wrap off and see what we're dealing with here. There's a paper here from June 1959 which says, "One day men will land on the moon and plough its fertile soils." Oh, that didn't come true. Ooh, well, look what we have here. Never seen one like this before. Nice little amp. Oh yes, I have. It's exactly the same as the one that I refurbished, or very similar. I recognise the style of it. It's off on volume and bass and treble. Around the back, just an extension lead. It says Selmer London WC2, patent pending. I wonder if they ever got their patent. This is 14314. Bet they started their serial numbers at 14,000. No plug on it for some strange reason. Not quite sure why that is. Yeah, no, don't know why that is. I think I'm just going to power it up, you know, and see if it works and then take it from there. Right, I've popped a new mains plug on and we're ready to power it up and see what happens. There's a jack socket on the back which I'm assuming is the instrument input. There's no other sign of where to plug. Anyway, turn it on. Not sure if that's a light, but nothing coming on there. Nope. Pretty dead to me. Okay, well, let's take the back off and have a look. It's a bit suspicious there's no light coming on, so let's see if we have any mains coming in the back. There we go. Look inside. Yes, that is the input jack there. Right, I'll show you inside. Right, here we go, a little printed circuit board, output transformer there, the amp's unplugged and switched off. 3 valves, they all seem to be in place, and power transformer, mains transformer. Speaker I don't recognise, ELAC it says on that, ELAC, ELAC speaker. Right, well I think, let's have a look. Don't like the look of this at all. I don't know if you can see this, but that's the mains in. So I'm immediately going to have a look and see what's going on underneath here. And at the very least we're going to need a new mains cable, which is not a problem, but that may be why we're not getting any power to it. Let's take that tape off and have a look underneath there. Well, it looks like, doesn't look like the joints are broken though, so I'm not sure whether that's well, just for my interest, I'm going to take my life in my hands and turn that on with those wires exposed, and just have a quick look to see if we're getting any mains at this point here. So I'll plug it in, and let's just have a quick little look on the meter here. Do we have any mains here? Yes, we've got power there. Turn it off again. So we've got 240 volts AC there, but there's nothing, no valves lighting up or anything. So I think the next thing to check will be the on-off switch, just to make sure it is actually a short circuit. So I'm just going to set my meter to buzz like that. I'm going to go on to the contacts of the on-off switch and nada. They should be shorted together. And I beg your pardon, I'm on the wrong contacts, so let's try that there. No, nothing there. Okay, so it's a 2-pole switch. Live and neutral are switched. Neutral is switched, okay. You can hear the thing buzzing. When I go to the live side, that's not switched. So basically there is a problem with that on-off switch. So all I'm going to do for the moment is just bridge it with a croc clip, and I just want to see if the amp comes on really. So I'm just going to take a croc to croc clip here and bridge that on-off switch to make it permanently on. That's okay, and again keeping an eye on this horrendous rat's nest here. Make sure we don't kill ourselves. I just really want to prove if the amp is actually, if it works and if it comes on. So on again. Ah, now the valves are lighting. I'll just show you in there. So we have the plugged in there, and we do seem to have something. Yeah, basically it's working. Horrible hum has just emerged now. Okay. Right. So fundamentally the amp is working, and we need to sort out the mains lead, and of course we're going to need to find out what all that hideous racket is. So I think the first thing, let me see. I wonder why they've made that on-off switch 2-pole. I don't think we really need that. I think I'm going to join the neutrals together and then bring the live in through the switch there, the side of it which is working. That means we don't have to change the volume control on-off switch. So I think I'm going to do that first and put a new mains cable on, because this is lethal, and this cable's all naff anyway. So I'll put a new mains cable on so that we're all nicely powered up. Then I'm going to change the valves, obviously, and see where we are from there. Here's the new mains cable coming in. I've put a P-clip there to hold it in place, and we come up to here. Ground is going to chassis ground. The neutral is now going straight to the primary of the mains transformer, and the live is switched by the working side of the switch to the other side of the mains transformer. I've removed the preamp valve just to give me a bit of access, and you know, it's a nice Mullard ECC83. I'll test these. They may be good, they may not be. And then it's probably an EL84 almost certainly, and this will be a rectifier, either an EZ80 or an EZ81. I'm hoping it's marked on there, but if it isn't, I'll have to do a bit of searching. But I've got both of those in stock, so the first thing I'm going to do is to change this preamp valve and this power valve and see if all that racket goes away. It may or may not. Okay, we've got it switched on again. Hummy. The off-on switch works okay. That's good. Now that could be filter cap, mains filter cap. But it's interesting, all that shash has gone away. I've put another Mullard valve in there. It's all a bit sensitive to being moved around. I think I'll pop another rectifier tube in there as well. Good, here's the rectifier tube, Brimar EZ80, almost certainly okay. It's just possible one side of it's down, that's why we're getting that horrible noise. I happen to have one in stock. I bought two recently. This is new old stock, and I used one in a Dallas Scala amp that I've just uploaded the video for. Very similar sort of amp to this. So we'll pop that in. I don't expect it to make any difference. And then the next thing we're going to be doing is taking the chassis out so that we can see it a bit more clearly. And of course, if we've still got that hum, I'll just dab another capacitor across this filter cap here and see if the hum goes away. And then we can take it from there. There's only a handful of components on these amps, so not much to go wrong really. But let's try a new rectifier valve first. Okay, as expected, the new rectifier valve has made no difference to the level of hum, but all that crackling and banging is gone. So I think I'm going to put the old rectifier valve back in, because nothing wrong with that. And I'm going to put the original Mullard back in and see if that is the culprit in terms of all the noise. Okay, job done. Original EZ80 back in, original Mullard back in, still got the hum, and I think there's some, okay, right, well that valve base and pins need cleaning. I'd obviously like to keep as much original as I can on this, so I'm going to remove this valve, clean the pins, clean the valve base, put that back in, see if it's stable in terms of the noise problem. Then I'm going to pop the original EL84 back in, see if that was the source of the noise. So this is quite bad, as you can see. Right, I cleaned up the pins of the valve with a bit of very fine emery cloth. Squirted a bit of deoxit in there, and that's now all completely solid look, so that's good. So that noise, well, I'm going to say wasn't coming from that valve. I suppose it could have been the valve base. So what we need to do now is to change this EL84 back to the original and see if that all the horrible noise comes back. That's our next job. I thought I'd put the Mullard on the orange valve tester just to see what it does, and it's just coming to the end of its test now. And oh, it's good, look at that. That's probably 50-60 years old, that valve, and it's still good, so that's great. So we've got a nice Mullard in there. I'll pop that back in, then I'm going to take out that new EL84, clean up the old one, the pins and the valve base, and pop that back in and see if that valve is the source of our noise or whether it's just dirty valve bases. I put this EL84 of unknown origin on the valve test and it came up good. This is the original one that's in there. So I'm just going to, the pins are a little bit bent, I'm just going to straighten up some of the pins. Not that easy to do. Just a little pair of flat nose pliers there and straighten them up a bit. Then I'm going to clean these pins, and what I do is I put a little squirt of deoxit on some very fine emery cloth like that, and I just use that to go around the outside of the pins to start with, like this. And then I do as best I can on the inside of each one, kind of like that. I don't manage to get to every surface, it doesn't really need it. This will make a big difference to any corrosion that was there. And that's it really, nothing more fancy than that. So we can pop that back in and see if that was the source of all that crackling you remember we heard when we first turned on the amp. So we'll pop that back in. May as well put these springs down now. Good, let's power it back up and see if that crackling comes back. The hum will come back, but for the moment I'm just trying to find out whether we have a faulty valve. And there's the hum. It's interesting, that hum, it changed its characteristics. This socket's not particularly good either. I'm going to change this socket because this, what's going on there? Right, that's okay, yeah. Very old socket this. Original, I would think. Anyway, that seems to work okay. So it's interesting, all that noise is gone. Working okay. Right, so it's just hum really, and I suspect it's the main filter cap would be my guess on that, especially as that sounds 100 Hertzy as opposed to 50 Hertzy. Right, I'm going to disconnect the speaker, and then we're going to take the chassis out. Now, how does one do that? Looks like you have to get a sort of a nut spinner or something on these two here, and that one there, I think it was 3. Ugh, it's not particularly easy, and not easy to get this out. That's a bit of a pity. Huh. Oh well, let's see what we can do. So I'm going to get out my large box of nut spinners and see if I can find something to fit. This is the sort of thing, I'm sure you know, this kind of hex nut spinner. Okay, well, would you believe the trouble with these as well, these are captive screws. Right, I don't think I need to undo that. That's going straight through the chassis, and it's probably got a nut on the other side of it. I think it's these here, that one, and that one. See, that doesn't work, that nut spinner. It's just a little bit too big, unless the nut's really loose. Put a bit of WD-40 on them all first of all. half of my problem in this business is getting chassis in and out. If you in a business yourself, you'll be nodding in agreement. They can be pigs, some of them. I've easily spent an hour on many occasions, not just once or twice, on many occasions, getting a chassis out. See, I don't really like this. Are these nuts here also going through and holding this all down? I mean, I could take the. I suppose I could take the baffle out, the whole assembly out. That might be an idea, actually. Think about that a second. Am I being a bit dim here? I take out the whole baffle. 1, 2, 3, 4. This whole thing will come out. I don't have to worry about taking the chassis off. Let's put a bit of WD-40 on these 4 and see if I can find a nut spinner. This is the problem. See that? Actually, funnily enough, this is too big, this nut spinner, but because that nut was loose, it will actually undo it. Can't get that off. Don't suppose we're going to get lucky twice. No, that one won't work. This one. The problem is, I know that because this nearly fits, I won't have one that actually fits. Let's try and get hold of some. I don't know what they'd be. A BA or something? Nut spinners? Yeah, probably. Yeah, I think I used to have them back in the day. Getting a bit lucky here though. 1, 2, it's just this one here. I'm using this spinner on an angle to just get a bit of grip. Oh yeah, we've got lucky there. Now they could have been total pigs, but actually all 4 of those came out quite well. Right, well, will this come up? Yes, it will. Okay, I'm being stymied by my own P-clip here holding the mains lead in, which I put in earlier. So that's a nice idea, but that can go in later. Right, so now, with a bit of luck. Yes, great. Now before I lose these, I just want to pick up these 4 washers here. I'll do 3, I've already lost 1. It'll be in there somewhere. There it is. Okay, well that was a good idea. I will put the class piece of workmanship of the case to one side, and let's get ourselves a bit of room here. Right, now look, we can get to the printer circuit board and everything we want to, which is brilliant. So there's the main filter cap there, look. First of all, notice how few components there are on this amp. We've got 1, 2, 3, 4, 5, 6, 7 resistors and 1, 2, 3, 4 coupling caps. And these are the really old resistors, look, with the paint splodges, also 1 meg. I haven't seen one of those for years. You know, I remember, when I first started out in electronics, I think I remember having some of these, as well as the modern carbon film ones. Anyway, that's the main filter cap. Is it a 2-stage one or a 1-stage? Let's have a look, see if I can see the legend on it. It's 275 volts, 350 volts surge, it says. Ooh. And 25 microfarad. So I think that's just a single stage cap. Okay, so the legend on this is not like anything I've seen before. So it says 32 plus 32 microfarads, that's fine. So it's a 2-stage cap. at 275 volts DC working, 350 volts surge. Okay, well, forget about that. Now underneath that, it's got 25 microfarads at 25 volts. So is this actually a 4-stage cap? It's got 4 caps in one. Right, not immediately obvious where those 4 caps are, if it is 4. There are the pads for it here. Those two are linked together, those two are linked together. I've never seen a cap like that before, not with the 25 microfarad bolted in. Of course there are many 32 plus 32s HT cans, so yeah, not totally sure about that. Right, I can see what's going on here. We have a ground. This is the smoothing cap, a ground, and we have 2 positives, so the 32 plus 32, and then we have a 25 microfarad which goes off and bypasses the cathode resistor of this EL84. That's the cathode bypass cap. Interesting, they put all those in one can. Yeah, very interesting. Never seen that before, but then every time I work on an amp there's something I haven't seen before. So what I'm now going to do is just measure where I think those HT caps are. I'm going to reconnect the speaker first. I just realised I've disconnected the speaker, so let me do that quickly. Okay, speaker reconnected. And we are back in hum mode. Now let me see if I can zoom this out so that you can see the meter. And I just want to measure across from ground to there. Oh, it's on AC. So I'd expect to have an HT. I haven't. Assume capacitor ground goes to. Right, see if we can measure across this capacitor. Right, we've got 224 volts on there and 260 volts on there. So those are the 2 HT sides of things. And that's the 25 volt side, that's got 6 volts across there. So it's here and here. So what I'm going to do now is rig myself up a 47 microfarad capacitor HT cap and just dab it across there, see if that hum disappears. There might be some other issue here because the hum changes when I just flex the board slightly, look. So it might be an issue with grounding of the board to the chassis, which we can have a look at. Might also be a solder joint. I can go over some solder joints, but let's prove that HT cap is good or bad by sticking another one across it. Okay, to do this I'm just going to, don't try this at home of course. I've got decades of experience doing this, so I'm going to put this what have we got here, 47 microfarads at 500 volts there, and I'm just going to try it to chassis first of all. Actually, it makes my life easy. I'm just going to clip this negative to chassis, make sure that it is negative. It is. Now I'm just going to dab this look onto, I just want to double check that point. It's there, was it? Yeah, 240 volts there, yeah. So let me just, there'll be a bit of a spark as the cap charges up. That's perfectly okay. There we go. Yes, it is taking away some of that background hum. Not as much as I'd expect. I can hear, you might not be able to hear that, but I can hear that it's actually changing the hum. So that cap isn't great. That's on the lower voltage side, so it's one side of that cap. And it's just probably just helping. 47 microfarads across 32. Right, I'm just going to discharge this now by touching on there. There we go, so that's now all safe. So that cap's not great, or it could be helped a bit, but that's not the main cause of the hum. The main cause of the hum is something earthy. Right, that hum goes down by about 50% if I take this entire assembly and move it away from my bench. I've had that before with, I'm under fluorescent lights here, about 6 of them for a bit of light for filming. And I've had that before where amps pick up hum. Now if I bring my hand, it's quite live, isn't it? Quite sensitive to that. So I think I'm going to have a look at this earth here, look. That goes to an earth solder tag, which is kind of screwed to the chassis, and that screwed to the printer circuit board, and that's how the printer circuit board gets its ground. So I think I'd like to have a little look underneath there, maybe clean that up. Probably similarly this one here. And then I'm going to go over some solder joints. I'm going to add another 47 or 22 microfarad cap across the main cap, just to help a bit more on the smoothing side. Then we will try again, and I might try it again in a quieter environment. So I've taken that bracket off of here completely, and yeah, it's probably okay, but it's been 60 years since this saw anything like shine on it. Let's do that. Don't need to worry about that side, and then we can just similarly just give the PCB a bit of a going over there, and that's improved that no end. So now we can pop that back on there like that, put the nut and bolt through. I don't know if that makes any difference, but certainly won't hurt. There we go, get a nice tight fix on there, and then this goes back on here like this. Whole thing's rotating there. Oh, that's very frustrating. Right, I've just made myself a little cap clip there to hold this capacitor. So we're coming on a positive here and a negative here, making sure to clear this hole here where the nut comes through. I think we should be okay there. Negative. I've tacked on a couple of wires to the printer circuit board, so we're going to come in here with this one. And we're going to come around here with this one. Put a bit of sleeving on there as well, since it's high voltage here. I mean, it's all a bit ridiculous really, it's high voltage everywhere, so but anyway, it's just an extra precaution. Going to get some sleeving. Wonderful invention, heat shrink sleeving. Absolutely love the stuff. Little lap joint there is perfectly okay. None of this is critical you only need to apply wire, I was going to say wire man's techniques, but you know what I mean, wire person's techniques these days to stuff that's super critical. Otherwise it just all takes forever and gets more complicated than it needs to be. Right, that's out the way of that bolt. This is good here. And we hardly even need to bother to shrink those down actually. So that goes to positive and that goes to negative, and that's the negative of the capacitor and that's a positive, so we're good there. I'll turn it on and then just make sure it works, doesn't go bang. There we go. So there's an underlying hum there which was smoothing cap hum, which I could hear. You might not have been able to hear that, and that will have improved it slightly. And the hum you're hearing now is this business. If I were to move this away, I can't really do that and show you. That does go down considerably. Right, so we need to have a little think about what, if anything, else we want to do here. Oh, I know. I wonder if the cathode bypass cap, the 25 microfarads at 25 volts, is good. So I might just I might put another 25 microfarads at 25 volts across the cathode resistor. The cathode resistor is, let me see if I can show you. This one here, that green one. It's the only power resistor on the board, so it's a bit of a dead giveaway. The 25 microfarad part of that is sitting across that cathode resistor there. Yes, I'm pretty sure it's there and there. Let's see if I can get on there with my meter. I think we did measure it, didn't we, at about 6 volts or something, but let me see if I can just firm up on that. Yeah, 7 volts across there. Now if we knew the value of that resistor, we could find out how much current's going through the EL84. Just let that voltage bleed away, and then we might just get lucky and be able to measure the resistance there. I can't really see what's written on there. It's just coming down a bit as the voltage is, still a bit of voltage hanging around here, you see, which is not very helpful at all. Just grounding that out. You can't measure resistances with any voltages around at all. So here we go. Okay, I'll make that 140 ohms. That's actually quite low, that resistor. I can see the 5% on it, which is annoying because I can't actually see the value of it. Right, I managed to get the schematic for this. It's a Selmer Little Giant. The same, well, a similar model to the one I worked on before. I think there are various incarnations of this. Anyway, I thought you might like to see it. Quite simple, really. Here's the preamp valve, 2 stages of gain and a bit of tone control. Straight through to the volume control, straight onto the grid of the EL84, cathode biased, and it is 150 ohms, that resistor. It's a bit low at 130, you might check that. And then there's the cathode bypass capacitor, look, which was part of the can containing this and this as well. And there is some resistance here. I thought there must be one somewhere, but it's not a very big resistor, that. 5K6. By big I mean sort of high power. Couldn't spot it immediately. So we'll see if we can find that and make sure that is 5K6, otherwise we'll have the wrong voltage here. I've been around a few of the resistors and measured them, and they're all way high. Like 270k resistor I'm measuring at 350k. There was a 10k somewhere, 100k is like 130k. So I might take a view on replacing some of those. I'm particularly keen to find that 5K6 first of all, and just see if we because that takes a little bit of power, that, not a lot, but you know, some power. It's interesting, there's 100k, look, in 100k feeding these. These are all very low current coming down here, absolutely tiny. Yeah, so there's the HT effectively, look, coming off here via the primary of the output transformer. There's a secondary of the output transformer, of course, which goes off the speaker. And that's interesting, got a little bit of a negative feedback here, this loop here, coming around via the volume control. How interesting, cool. Yeah, sort of a negative feedback there. That's a strange way of doing it. Cool. I've never seen that before. Via the volume control. Huh. Oh well. See something new every day. And that's about it, really. Nothing much more to say about that. Let's see if we can spot that, that 5K6 resistor there. See what value that is. Well, you can see the problem here. The resistor is here, I think. Yes, there it is. And 6K, 7K, look. That should be 5K6. So I want to change that. And the thing I'm a bit curious about, there's a resistor here marked 4K7. There, and it seems to be on the input signal. It seems to be attached pretty much to the input signal cable here. Let me see, that goes there. Yes, it goes to one side of the input signal, and then the other side of that goes to one of the pins of the valve. Okay, you might think, oh, okay, fair enough, but I can't measure any resistance across there. It's open circuit as far as I can see. Even on my 200k meter setting, I just get nothing there, which is weird, because you'd think if that were the case, even on 2 meg, look, I'm getting 1.2 meg or something. Unless I'm being silly here. What if I can't see it on the... Ah, I know what it is. Yeah, okay. It's a capacitor, I think. Oh no, 0.01. I wonder if that's a capacitor. I mean, that would be the right place for a capacitor. I'm not so good on these very, very old radio components. Obviously I recognise a resistor, but I think it's interesting that you know, all the resistors have got these you know, these marks. For example, that's 1 meg, brown, black, green. That's a 1 meg, and here's like a 270k resistor there, red, purple, yellow. But none of this doesn't look like any of the other resistors. It does say 4K7, so I reckon that's maybe 4,700 picofarads, or 4N7 capacitor. That's my guess on that. 4N7 capacitor. I might replace that actually. It says on the diagram here 0.1, 0.01, so 10 nanofarads. That's multiplied by 1,000 to give us milliamps, and it's got 46 milliamps going through the EL84, which is on the hot side. But that's what it's designed to be, so you know, I won't mess with that. I prefer something like about 30 milliamps, but anyway, that's fine. To change that, by the way, we could upgrade that resistor to a 220 ohm or something and bring the current down, but I don't think I'll do that. That's how they designed it, so that's how we'll leave it. Right, so that's it for tonight. Tomorrow I will have a go at changing some of those resistors. It won't make any difference to the sound of the amp, but it'll bring the whole thing just more in tolerance with what it's supposed to be doing. Well, I thought you'd be interested to see this. This is the capacitor that I took out of the input to the PCB there. And it's marked 4K7, which I correctly guessed was 4,700 picofarads, or 4.7 nanofarads. So a couple of things about this. First of all, this is an amazingly small capacitor for 4.7 nanofarads. It's really quite tiny. In comparison, here's what I'm planning to put in there, a kind of nice new old stock mustard capacitor to make it look a bit more authentic. And this is 10 nanofarads. So considerable difference in size there. Not quite sure how they get 4.7 nanofarads into there. If anybody knows, let me know what the construction of this capacitor is, and I'm sure one of my more loyal and more knowledgeable subscribers will tell me if this is a good un. Just dropped a hint there. Now on my meter here it's 3.8 nanofarads, so it's yeah, neither here nor there really. So I'm going to put, the original schematic calls for a 10 nanofarads, look, 0.01, so I'm going to put a 10 nanofarads in. I'm going to put this this nice mustard capacitor in here. I've got a load of these. If anybody wants any of these of various values, just drop me a line via the website, and I'm happy to send you a few. So this is what I'm going to put in. Actually, this is this is 15 nanofarads as it happens. 1, 2, 3, 15 nanofarads, that'll do. That's perfectly alright. Okay, we'll pop that one in, and then the next thing I'm going to do after I've done that is I want to measure the HT there, and then also measure it there, and on the anodes of these two valves here. That's before we start changing that resistor, that resistor, that resistor and that resistor. These are all very high, so I suspect these will be quite low. Oh, it's interesting, I've actually marked the voltage. That's really unusual. I don't think I've ever seen that on a schematic. 86 volts and 88 volts, so we'll be able to see what those are in a moment. I would imagine they'd be low. Can't see how they can't be low, with that is now 7k if you remember. This is probably 130k. These are 300 something k, so I imagine these are quite low. Anyway, let's put the capacitor in, and then we'll do some measurements. So we'll write the voltages down on here, then we'll do the resistor upgrades, and then we'll see what the new voltages are. There we are, that capacitor's in. It doesn't look amiss in there, it's a vintage capacitor, so that will look quite nice. Now, let's do some voltage measurements. Right, the junction of the two 270s is this point here, 166. So this here is 166 volts. That's here. And finally we want to go on to pin 1 and pin 6 of the valve. So pin 1 is here. What's going on here? Oh, maybe it's there. 67, 1, 2, 3, 6, 67 and 59. So our instincts were right here, 67 and 59. So let me just recap what we've done there. We've done all the measurements now, and look, HT is 283 volts, that's 239 volts. This is 166 volts, and this is 59, should be 88. This is 67, should be 86. So 20 volts difference, or like 25% different there. Quite significant difference. Meaning this preamp valve is running on quite a low plate voltage. So I'm going to change that, and that all in one go, and then we will see what these voltages go back up to. I'll do that off camera, and then I'll rejoin you when I've done it. Here's this little 270k, one of them anyway, one of the anode resistors, and it's measuring, if I can get the probes on, 340k. Absolutely miles out that, so we'll change that one. Just one more to do, I've just got the other 270k to do. And here's the other 270k. Let's see what that's measuring. 350. Significantly out. 27, it's about 20% out at least, just off the top of my head. So that's the last one we're going to change, and then we'll re-measure those voltages. Right, 4 resistors replaced, and we're now going to go around and measure those voltages again. So let's have a look. First of all, our HT, which was 283, I don't expect that to have changed very much actually. If anything, I might expect it to go down since we're pulling a little bit more current. 283, 275, so again, that's exactly what I would have expected. Just a little bit of a drop in the HT, because we're pulling a little bit more current. So our 283 here has gone to 275. Okay, let's see what we've got now, the other side of the 5K6, which I would expect to be a little bit higher. So it was 239, now it's still 239, okay. Oh, I know why, yes, yeah. Okay, so it's still 239 there. And the reason for that is, although that 5K6 is now lower in value, this is all pulling more current. But these are both reduced in value significantly, pulling more current, dropping more voltage across there. So although we did, that would have caused an increase in voltage, that has now been eaten up by the increase in current coming down here. Now I would though expect to see these anode voltages be a little bit better. Let's first of all see what we've got on the here on this 166 point. 168. That's gone up to, and not very much. Interesting, it hasn't made a significant difference. So that's gone to 168. And what are our anode voltages now? Pin 1, $79, pin 6, 1, 2, 3, 4, 5, 6, 66 and 79. Okay, so we have now got a bit more voltage on these anodes. Not a lot, that's gone up to 66, and that's gone up to 79. So we've got an extra 12 volts there and an extra 7 volts there. Not as much as I thought that would go up actually. But of course the reason is we've now reduced these resistor values, so there's less, so more currents being pulled. I don't know, it's a sort of a self-chasing loop in some ways. Oh well, we got an extra 12 volts on there, which is significant. In 66 volts it's an extra 20% or something, and an extra 15% there, so at least they're a bit closer to what they should be. It should be 86 volts it says there, but of course so much depends on the AC input voltage as well. But these resistor values are now correct. It's closer to what it should be, let's put it that way. Make sure it still works. the same to me. I don't know. It's very difficult to tell without doing an A/B comparison, but anyway, it's all up to spec, and that's pretty much all we can ask for. As the saying goes, I don't like the saying, but in this particular case it's very apposite. It is what it is, this amp. It's very cheap and cheerful, very low quality, grungy, low power amp with a not particularly good speaker. I'm going to call it a day on that. I'm quite happy with that. The hum's gone down a fair bit, which is good, and it'll go down even more when I move it away from the bench here. So we'll put it back together and give it another play, I think. But I'm happy with that. We've done some good work on that amp. It's up to spec now. Now I'm also going to treat this to a new jack socket actually. I mean, it's working okay, but this is actually pretty ancient now. Right, now next is my new fangled mains cable. Right, well, this just stops the cable from being pulled too hard. It just had an old staple in it before, literally from a staple gun. Cup of tea on the go, of course. There we go. That's a lot better arrangement than it was before. Good. New jack socket, and I'm wondering whether to shorten this. It's an awfully long piece of cable, this. Where does it go? It goes, no, it goes all the way over here. I wonder why they decided to put the instrument. Actually, this is really quite amateurishly done, isn't it? These holes here. Were there two at one point? Yeah, okay. So actually that's not far off the right length, that. I thought it might just come up to here, but right, let's find ourselves a nicer socket than this. Okay, new jack socket installed. I use the same nut, quite a nice nut that actually. And when I went to put my nice moulded mains plug, when I went to put the back on, my nice moulded mains plug wouldn't go through here. So I had to chop it off and put on a hand wired one so I could bring the cable through this little hole here. I'm not convinced this is original, this back. Maybe it is. It's really hacked out, and it doesn't fit here. It's not flush. It doesn't go down flush into there. I got a feeling this might have had a kind of thinner, almost hardboard back on it, and somebody has made this. This is really amateur. This would never have left the factory like this, even though these were quite cheap and cheerful. And I think, yeah, it's interesting. Yes, the more I look at it, they've taken the Selmer sticker. Look, that would obviously have had something holding it on there and there on the original back, and they've just taken the stick off and stuck it onto here, and it's been hacked out. I don't know who did this. Pity. Not the original back. Also, it wouldn't have been this just plain wood here. It would have been black, some sort of black stuff. Anyway, this is good enough, perfectly good enough back. It's just it's not original. So we are done with this amp. We will put these 4 screws in. Turn it the right way up. Oh, that's a pity. It's got a foot missing too. I've just noticed. So we've got these little feet, 1, 2, 3, and oh, someone put a nail in there. That's very useful. If you haven't got a foot, put a nail in. Why not? There we go. I don't know why someone's put a nail in there. Maybe they had a bit of wood nailed on there or something for the extra foot. I might see if I've got something I can fashion to fit there. Don't like to let it go out like that because it'll be wonky when it stands up. But before we get involved with that foot, which will be the last thing, let me see if it works still and what it sounds like now it's all back together. There we go. Right, excuse the strange setup. I've had to bring the amp into another room because the buzz level in my workshop was just too high. It seems very susceptible, the amp, to pick up. You can probably hear it buzzing away now. Of course, there's no metal in this. It's just a wooden box, so this circuit may as well just be on the bench. There's no screening of any description to screen it from pickup. So I don't know whether these were always like this, but this can only be played in a low electrical noise environment. You can't have fluorescent lights and stuff. In fact, I've just got one floodlight on me now, just an ordinary halogen floodlight, and if I had to bring an extension lead in from another room. If I plug the light into the extension here, hope you can hear that dramatic increase in buzz. So it seems very susceptible to pick up. Surprisingly loud. That is really surprisingly loud for a couple of watts. That really is overloading it, but on moderate settings. Rumour has it that Ray Davis recorded You Really Got Me on an amp similar to this, or maybe that Dallas Dakota I just did a video on. And I'm no guitarist, but just having a go myself. If you see what I mean, it sounds exactly like it to me. That's exactly what You Really Got Me sounded like. You know, at those levels and in a quiet acoustic electrical environment, that's perfectly acceptable. Bring that anywhere near any fluorescent lights and you're in real trouble. I think that's all I can do on that. I had a little play around with some aluminium sheets, earth sheets and that sort of stuff, bring it up to the back and think if it's worth putting an aluminium sheet on the back. It didn't, to be honest with you, do that much to reduce the noise level. So obviously want to go on and on and on with this kind of thing. I could easily spend several more days just hunting down noise, but I think that's probably a sensible amount of work to do on this amp. Well, I woke up this morning, didn't get sleep last night. Said I woke up this morning, didn't get sleep last night. 'Cause me and my baby, we done had a good fight. First line of a blues song is always sung a second time. I said the first line of a blues song is always sung the second time. That way by the time you get to the third line, you've had time to think of a rhyme. Oh yeah. So there's a couple of things about the design of this that are a bit strange. First of all, this volume control is very weird, the way it you know, it's not on the input like you would normally expect a volume control. It's here. It's controlling the signal that goes to the control grid of the EL84, but you kind of expect that to go to ground, but it doesn't. It goes round to one side of the output transformer. That's strange. Don't understand that. Maybe common, I just don't know about it, but there you go. Anyway, weird. But I don't also like having mains on the volume control, which is exactly what you've got. You've got two fully volt mains coming in right onto the volume control here, so the chances of mains pickup are very high. Anyway, don't know if you can hear that buzzing away. I then made myself up a little aluminium plate here, and when I bring it up to here, that is significantly reduced. I think that's pickup from my fluorescent lights, but it doesn't matter where the pickup comes from because it's very susceptible to pickup. So I'm kind of tempted to see if I can make some kind of shield. It's kind of crying out for one, really. You know, it kind of come up from there and across there, that sort of thing, you know. Particularly easy to do. Particularly you've got to think about how you're going to secure it. Grounding, it's easy, you just put an earth tag on down to there. I suppose we could think about having like a tray like that, so it comes up and we screw in there and there and there and there. That would be possible, that would be quite nice. It's probably the best bet. I think for the sake of 20 minutes I'll make myself up a tray that goes across here. Then we don't have to secure it or anything, we can just literally earth it and see if that does reduce some of this pickup. Don't want to go on forever, it's all, you know, I'm doing it for a fixed price for the customer, so, you know, I've already spent way too much time on it. But anyway, let's just see if we can improve that slightly. And one of the slight downsides of a tray arrangement is it will slightly impact the ventilation. Not a lot, because when it's up the right way up, the heat will go up that way and come out here, so I think we're okay there. But we might have to rethink about this again and have this come out of here, a little hole here, because obviously this tray will be across here now. I'm not worried about that because this is not an original back, so I'm not worried about doing that. It's a bit nicer than that anyway. It's a bit naff, don't you think, coming out of there? Why don't we do that anyway? Let's means taking the mains plug off again. Takes a surprisingly large amount of time to put a mains plug on, a UK mains plug. It's not a trivial thing. So we'll have the mains cable coming out of there. Right, we don't need to worry about that for the moment. Let's see if we can make up this tray. Okay, it only took me about half an hour to knock this up. That's going to sit, in theory, in there like, I haven't tried it yet, it should go. Yeah, it's a very good fit, that actually. That's going to sit in there like that. Earth lead, which will eventually solder onto the main earth, but for the moment I'm just going to clip it on like this. I want to see if this actually does anything. So let's turn it on. Where is the power for this? Has it gone? Here. Right. On again. Hopefully we'll hear a nice buzz. Got lots of lights on in the workshop here to do the filming, and they do put out quite a lot of noise. Okay, I can hear that quite clearly. Hope you can. So let's see if my little thing does anything. Significant. Look at that. That's like a 75% reduction. Excellent. Well, I think we'll go with that. What do you reckon? Just 4 little screws in there, and there. Easy to take out if anybody wants to. Everything I've done is restorable to the absolute original. If somebody wants to, they can take out my extra smoothing capacitors. I can take this plate out. Yeah. I know. I've got a great idea. Let's put the plate in this way round to make it absolutely impossible for the next person to get the screws out. What do you reckon? You'd have to get a little tiny screwdriver in there. No, let's not do that. Right, well I'm going to, yeah, well, I'm happy about that actually. Very pleased. I'm going to mark this up on here, like so. This fits amazingly well actually. Didn't particularly do any precision measurements, just fairly rough and ready. So we can mark through there, 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 and there. And put a little drill through there, solder that on, find 4 little screws that will go there, and oh yes, must remember to do this mains cable. Right, let's get this screwed in place. Okay, 1, 2, 3, 4 screws in there, and the earth is earthed down. I've taken the mains plug off again. That's the 3rd time I've done it, so that I can now pass the cable through this hole. Like so. That's a lot neater. Now this needs to come through here to go off up to here. Getting there slowly with this amp. Been quite a long haul. I reckon I've spent it's got to be 6 or 7 hours. However, it's the sort of job I like to do, as opposed to trying to repair a, you know, transistor amp or something like that. Right, that's all okay. Now I think we can finally put our screws in. That's from the mains plug. I've got to put the mains plug back on yet. That's that. Right, just going to pop the mains plug back on and then we'll give it a final test. Well, would you believe I've been about another 3 hours on this amp, just chasing this hum, this buzz. This does make a difference, but it's still quite loud. So what I've had to do is make myself up a little shield for the input here, and that does quite significantly quieten it down. So that's without. Trouble with this amp is I'm just going on and on with it, and you know, it's taking up a lot of time. Just realised that's not long enough if that's going to go down in there. No, not quite long enough, right, to make a longer one. Yeah, it's been a bit of a so-and-so really on the buzz side. I've also moved the input jack to here, because this is where the preamp is on this side, and the lead was going all the way across here to over here, and you know, getting quite a bit of pickup there. I don't think this amp will ever be great in the pickup department, just because of the way it's designed and made. I suppose ideally we should make a metal back for it, but I don't have, well, it's quite time consuming. I don't have the aluminium handy either. So we're going to put that on there with a bit of a longer lead here, and then give it another go. It's been a bit of a pain, this. Right, I've got the amp set up in the kitchen, which is quite a quiet environment, electrically noise-wise, and it's not too bad. It's got an underlying hum buzz, especially if you turn everything up. You can hear that quite loudly, but on moderate volume settings, and particularly it's very affected by this tone control. It's acceptable. That's quite loud there. Without going into it too much, for example, this tone control, the back of it is hard up against the mains transformer. You couldn't even get a piece of paper in between it. So obviously that's going to pick up hum straight from the mains transformer. So the design on this leaves a huge amount to be desired. They, I don't think they really bothered to design them back then. They just sort of threw them together really, with no thought for anything. Anyway, there you go. I think it's the best we can do with this. We spent a long time on it, and I don't think we can get it any better than this.
You really got me now. You got me so I can't sleep at night. Oh yeah, you really got me now. You got me so I can't sleep at night. You really got me. You really got me.
And just one final thing, I did manage to fashion a little foot there, same height as those. Obviously doesn't match them, but at least it saves it wobbling, which it was doing. I didn't have anything like this, I'm afraid. Better than nothing. Right, that's another one under the belt. I hope you enjoyed watching that. These are fun and interesting little amps to work on. And yeah, they produce an interesting sort of grungy 60s sound, if that's the sort of thing you like. Not quite sure why they're so valuable these days. Maybe it's just all nostalgia. So in the end, we spent quite a few hours on it, 8 or 9 at least hours on it. So we're on minimum wage again, folks. If you too want a minimum wage job, become an amplifier technician. There you go. There's a tip for you. Well, thanks as always for watching, and I'll see you on the next one.